Welcome to section 5.5, multiplying and dividing complex numbers. Multiplying complex numbers is simply using FOIL. You've used FOIL before with radicals and with binomials. You're going to do the same process with multiplying complex numbers here. Let's do a complex multiplication problem. 7 minus 2i in standard form times 4 plus I. Our FOIL process is first, outer, inner, and last. First, we're going to multiply 7 times 4 and get 28. Outer, we're multiplying 7 times I, giving us 7i. Inner, we're multiplying negative 2i times 4, giving us negative 8i. And last, we're multiplying negative 2i times I, giving us negative 2i squared. Let's go ahead and simplify that to negative 2 times negative 1, which equals 2. Now let's combine our first, outer, inner, and last. We would have 28 plus 7i minus 8i plus 2. 28 plus 2 is 30. And 7i minus 8i is negative I. So we have our answer, 30 minus I, written in a plus bi form. When we multiply complex numbers, we begin to talk about different things like the reciprocal of a complex number. So if our complex number is a plus bi, the reciprocal would be 1 over a plus bi. Another word for reciprocal is multiplicative inverse. Reciprocal and multiplicative inverse are the same thing. So in a couple of your problems, you're going to be asked to find the multiplicative inverse. That just means take your complex number and put it in the denominator with a 1 as the numerator. Another term that we'll use as we divide complex numbers is the word conjugate. You first learned that word when you dealt with radicals and you had to multiply by the conjugate to get rid of the radical in the denominator. We're going to do the same thing here, because when we have a rule about dividing complex numbers, I is not allowed to be in the denominator. So we will multiply by the conjugate to get rid of the I. So if a plus bi is our complex number, its conjugate is a minus bi. So we'll use those steps and those terms when we divide. Okay, let's find the multiplicative inverse of the complex number 2 minus 4i. That means we take 2 minus 4i, put it in the denominator, and put 1 in the numerator. Since we have a rule about I not belonging in the denominator, it's not allowed to be there, to get rid of that I in the denominator, we have to multiply by the conjugate. So we're going to multiply by 2 plus 4i over 2 plus 4i. Multiplying by the conjugate will get rid of the I in the denominator. In the numerator, we're multiplying 1 times 2 plus 4i, which gives us 2 plus 4i. And in the denominator, we're using FOIL. So let's step over here and do our FOIL process. 2 times 2 is 4. Outer would be 2 times 4i, 8i. Inner would be negative 4i times 2, negative 8i. And then last would be negative 4i times positive 4i, negative 16i squared. Let's simplify this last piece. This would be negative 16 times negative 1, or a positive 16. Okay, combining like terms, these two equal 0, and then these two get added together and equal 20. So our new denominator is 20. Okay, we're going to separate these pieces so that we can reduce and write it in a plus bi form. So we have 2 over 20 plus 4 over 20 I. I is out to the side. It's not in the top or the bottom. 2 over 20 reduces to 1 over 10, and 4 over 20 reduces to 1 over 5. And bring down your I. There's your answer. That's the multiplicative inverse of 2 minus 4i. Okay, let's do a division problem where the denominator has an I in it. Let's divide 8 plus 6i by 2i. I'm going to do this problem for you 2 different ways. Let's just leave it as it is and multiply the bottom and the top by I. That's all we have to multiply by to get rid of the I in the denominator. That gives me 8i plus 6i squared in the top and 2i squared in the bottom. Now let's simplify those I squareds. Eight I minus 6, because the plus 6 gets multiplied by the I squared. I squared's negative 1, making that a negative 6. And then the bottom is 2 times negative 1, negative 2. Okay, let's pull it apart and rearrange the top to be a plus bi form. Negative 6 plus 8i. Negative 6 is over the negative 2, and the 8i is over the negative 2. Negative 6 divided by negative 2 is positive 3. 8 divided by negative 2 is negative 4i. The other way to work this problem would be to reduce it first, since 8, 6, and 2 have a common factor of 2. We could reduce it to be 4 plus 3i over I, pulling out the 2, factoring it out, and canceling it. And then we simply multiply by I over I again. And when we do that, we have 4i plus 3i squared over I squared. The I squared is negative 1. So we end up with negative 3 over negative 1 plus 4 over negative 1 I. Now let's reduce. Negative 3 over negative 1 is a positive 3. 4 over negative 1 is negative 4. So either way. Now let's do a division problem where we have a binomial in the denominator. 5 minus 15i over 3 minus I. Since the denominator is a binomial, I have to multiply by its conjugate. The conjugate is 3 plus I. This accomplishes getting rid of the I in the denominator. So in the top, we have a binomial times a binomial. So I'm going to do my FOIL step over here. 5 times 3, 15. 5 times I, 5i. 3 times negative 15i, negative 45i. Last would be negative 15i squared. This will be negative 15 times negative 1, which is a positive 15. Okay, adding the real parts, I have 15 plus 15 is 30, and 5i minus 45 is minus 40i. That's my numerator. 30 minus 40i. The denominator, FOILed out, is going to get rid of the I. If you remember, multiplying by the conjugate will remove the I. 3 times 3 is 9. 3 times I, 3i. 3 times negative I, negative 3i. Those are going to equal 0 in a moment. And negative I times positive I is negative I squared, which is negative 1, which is positive 1. These equal 0, and then 9 plus 1 is equal to 10. So my new denominator is 10. Okay, let's separate the 30 over 10 and the minus 40 over 10. 30 over 10 is 3. 40 over 10 is 4i. And it is a complete coincidence that that turned out to be the same answer as the previous problem. Not meant to be that way, but it worked out that way.